Hi guys, this is Mr. Urrego, and today we're going to learn how to graph sine and cosine functions with a vertical shift, up and down. That's it. Now, we have a function, y equals half of sine of x minus 1. First things first, we bring our function, our general equation. We identify what's our amplitude, which in this case is the absolute value of 1/2, which is 1/2. All right. My frequency is b. In my case, because there's nothing in front of the x, your frequency is 1. Then we find the period. So now let's get rid of some space. Oh, before we move that away, C, there's no horizontal shift. If you notice, there's nothing with the x. So there's no horizontal movement. But at the end, after my function, I have a d value, which is -1. That means my function is going to move down one spot. If it's positive, it's going up. If it's negative, it's going down. So from here, I want to find the period of the function. The period is always 2 pi divided by my b, okay? Which in our case, the frequency is 1, therefore the period of the function is 2 pi. Once I have this, I find the increments. How do you find the increments? You take the period of the function divided by 4. Remember, I divide my function into 4 pieces. And that's going to give me 2 pi divided by 4, which you simplify, you get pi over 2. Okay, and like I said, this is vertical movement, so all my function is going to go down 1. Let's get into our graph. Amplitude is 1/2, -1/2 on the bottom, period is 2 pi, increments pi over 2. Okay, so from 0 to pi or to 2 pi, we're going to call that 2 pi. That's going to be the period. Therefore, this is 2 pi. Therefore, this is pi, and this is half of that, which is pi over 2, and this is 3 pi over 2. Okay, which are your increments. Remember, my increment is pi over 2, so from here to here is pi over 2, plus pi over 2 gives you pi, plus pi over 2 gives you 3 pi over 2, plus pi over 2 gives you 2 pi. Those are the increments. We need to think about the critical points of my sine function, which are this. As we can see, these are five critical points. My sine function will always start the x-intercept. Then it goes to a maximum if my amplitude is positive, which it is right now. And then it will go back to x-intercept, go back to a minimum, and finally end up in the x-intercept. So let's start. X-intercept, that's where my start. Then I go to my maximum. Then I go to my x-intercept. Then I go to my minimum. And then I go back to the x-intercept. Okay, when I say maximum, maximum is with the amplitude. Minimum is with the negative amplitude, which I went too far. So my negative amplitude is right here. Okay, so maximum and minimum. Amplitude and negative amplitude. Now that's my function. But again, I'm not considering the vertical shift. So let me just dash this line. So now, this is my function without movement. Let's move it. Let's do green for that. So vertical shift means every single point is going to move down or up depending on what you have here. Right now it's -1. So this point goes down. This is half. This is 1. Okay, so this point goes down 1. This point is at 1/2. It goes down half and another half. This point is at the x-axis. So this is going to be half 2 boxes and another 2 boxes. Okay, this point half and half, this point half and half. Okay, so if you notice, I moved the x-axis all the way here. Okay, it went down 1 because this is -1/2, and this will be -1. Okay, so I moved my points, now I connect them. And this is the graph that I'm looking for. Okay, remember, my graph continues to the right, my graph continues to the left. So if I'm going to keep graphing, it will keep going to the right and to the left, right? So that's in terms of my domain and range. Let's write domain and range. So my domain for any sine or cosine function is going to be from -infinity to +infinity, and the range depends on the amplitude. Right now, remember, I move my function down 1, right? So my maximum point right now is -1/2. That would be my maximum point. My lowest point, I was at -1/2, and I moved one unit down. So this is -1, and 1/2, which is negative 1.5. Okay, negative 1 and 1/2, or negative 1.5, comma, negative 0.5. All right, and that will be my range as a decimal and as a fraction. Either one of them will be the same answer. Let's do another one with cosine. Let's bring our equation, general equation. My amplitude is negative 2, or absolute value of negative 2, right? Which is going to be positive 2. But because it has a negative, that means this is a reflection over the x-axis. So it's going to be reflected down. Okay, my frequency is 1/2 in this case. There's nothing else. There's nothing adding or subtracting the x. That means we're not going to have a horizontal shift. But there's something on the outside of the function, which is your d value, and that means my function is going to go up 1. Our plan for all these functions that have vertical movement is, let's graph this, we put the points, and then we move those points either up or down. That's my plan. All right, let's find the period of this function. Let's get some space. So the period of the function is 2 pi over b, 2 pi over 1/2, right? Let's make the top fraction, and that's going to give me 4 pi divided by 1 times 1 is 1, which is 4 pi. Okay, my increments is the period of the function divided by 4, always. 4 pi divided by 4, my increments are going to be pi. All right, let's get this information into the graph. Okay, so now we have the information here. So I have my amplitude and positive negative 2. Okay, the period is 4 pi, so this is going to be 1 pi, 2, 3, 4 pi. My increments are pi, that's why I did 4, 2, 3, and 4 pi. So this is a full period from 0 to 4 pi. My critical points. Now, if you notice, I started with a minimum. How come? Because my amplitude is negative. Okay, therefore my cosine will start with my minimum value, and my minimum value happens at my negative amplitude. Okay, so at 0 I'll start with my minimum, then I start with my minimum, that's my starting point, and then I go to the x-intercept, then I'll go to my max, which happens at my amplitude, then I go to the x-intercept again, and last, my minimum value, which happens at my negative amplitude. Okay, remember, this is not a V shape, okay? It's a cosine function, therefore it comes with a graph. Comes with a nice little curve, okay? All right, now is this the curve that I'm looking for? No, the one that I just did is this. I'm not considering my vertical movement. So to do that, I just move everything 1 up. My initial point goes up 1. This up 1. Maximum up 1. So this is 3, right? My x-intercept goes up 1. My minimum value goes up 1. And now this is the function that I want. So I come from a curve my maximum, curve, and curve my minimum. Okay, and this is my function with the vertical movement. Remember, if you have a positive, your function will go up, negative goes down. Okay, so that's the idea about the vertical and horizontal movement. One more thing, they will ask you for the domain and range. The domain is easy because you know that the domain, remember, this is going to keep going and this is going to keep going, right? To infinity and to negative infinity. So my domain is simple by now. Is negative infinity to positive infinity. But the range is the one that is tricky because I got this movement, so my highest value is going to be 3, and my lowest value happens at -1. So now that's my range. That's going to be the tricky one. Remember that the range is your y value. Okay, guys, that's it for today. Like the video, please. If you're learning, subscribe to the channel. and I'll see you in the next one. Thank you for watching. Bye-bye.